Okay, so we're going to go through some extra examples with absolute value inequalities. So this first one, the absolute value of 3x minus 2 is greater than or equal to 8. My absolute value is already isolated. So I can say 3x minus 2 equals 8. 3x minus 2 equals negative 8. So I'm setting it equal, whatever's inside the absolute value here, I'm setting it equal to 8 and to the opposite of 8. So when I go ahead and solve for x, I get 3x equals 10. So x is 10/3. On the other side, I get 3x equals negative 6. So x is negative 2. Okay, when I graph this, negative 2, 10/3, let's test our intervals for shading. So to the left of negative 2, let's try like negative 3. Is the absolute value of 3 times negative 3 minus 2 greater than or equal to 8? I end up getting the absolute value of negative 11 is greater than or equal to 8. Is that true? And some of you might be saying, no, negative 11 is less than 8. We learned that a long time ago. But the absolute value is positive, so 11 is greater than 8, so I know that we are going to be shading to the left of negative 2. My guess is that anything in between here, let's try 0, isn't going to work, but let's test it out. The absolute value of 3 times 0 minus 2 is greater than or equal to 8. I get the absolute value of negative 2 is greater than or equal to 8, which is not true. 2 is not greater than 8. To the right, let's try like 4. The absolute value of 3 times 4 minus 2 is greater than or equal to 8. The absolute value of 10 is greater than or equal to 8, which is true. So I'm going to shade to the right. Okay, so I'm shading wherever my solutions are true. When I substitute them back into our inequality, they make a true statement. The absolute value of 1/2 x plus 4 is less than 6. Once again, my absolute value is isolated, so I'm going to go ahead and set 1/2 x plus 4 equal to 6, and also set it equal to negative 6. So now I'm going to solve these separately. 1/2 x equals, I would need to subtract 4 from both sides, so I get 2. To get rid of that 1/2, I would multiply both sides by 2, so I get x equals 4. On the other side, when I subtract 4, I get negative 10. So when I multiply both sides by 2, I get x is equal to negative 20. Okay, so here's negative 20, here's 4. Let's try a value to the left of negative 20. Let's do like negative 22. I'm choosing an even number because when I substitute it in, I need to multiply by 1/2. So it's just going to make my life easier. So I have 1/2 times negative 22 plus 4 is less than 6. So I get the absolute value of negative 11 plus 4 is less than 6. Negative 7. Is the absolute value of negative 7 less than 6? No, because that would tell us 7 is less than 6. So I know I'm not shading to the left. My guess is since we didn't shade to the left, we're probably going to be shading in between, but we need to make sure. Okay, I'm going to try 0 because 0 is between negative 20 and 4. So the absolute value of 1/2 times 0 plus 4 is less than 6. Is the absolute value of 4 less than 6? And it is. So I'm guessing that this is what our solution is going to be, all those values between negative 20 and 4. But let's double check. Let me try something like 5. Actually, let's do, let me erase that. Let's do 6. Okay, once again, the reason why I want to do 6 is because that's just making my life easier with the 1/2. So I get 3 plus 4 is less than 6. 7 is not less than 6. So everything in the middle is our solution.